New anomalous zones of the Earth, where the planet is literally breaking. Thwaites Glacier, West Antarctica. Glacier is one of the most important blocks of ice in West Antarctica. Its front flows directly into the sea, and much of its base lies below sea level, which allows relatively warm ocean water to reach it from underneath. Through cracks and cavities, this water penetrates under the ice and melts it faster from below, weakening the anchors that used to hold the entire ice mass in place. Scientists warn that a full destabilization of Thwaites could add several tens of centimeters to global sea level and, even more importantly, trigger the breakup of neighboring glaciers that are dynamically linked to it. This would turn Thwaites from a local glaciological problem into a global anomalous zone on which the future of many coastal megacities depends. Crucially, these processes are already underway. We are talking about changes over the coming decades, not some abstract threat centuries from now. Greenland fjords and megatsunamis. On Greenland's west and east coasts, large glaciers end abruptly in narrow, deep fjords. In these places, huge chunks of ice and even sections of rock walls regularly collapse into the water, creating extremely powerful local waves. In a narrow fjord, the energy of such a collapse cannot spread sideways, so the wave height near the shore can become anomalously large compared to the size of the initial landslide. Events like this are considered one of the mechanisms that can generate megatsunamis. A massive slope or ice platform failure produces an impulse that then propagates through the fjord and can be recorded as unusual seismic and hydrodynamic signals around the globe. Greenland's fjords are especially dangerous because shipping and tourism are rapidly expanding there, while monitoring of unstable slopes and ice masses is still far from perfect. This is a clear example of a zone where melting ice, geology, and human activity combine to create a new category of risk. The Nankai Trough, Japan. The Nankai Trough is a long underwater fault zone off the coast of central and western Japan, where an oceanic plate slowly dives beneath the Japanese islands. In the past, this area has produced multiple very powerful earthquakes with magnitudes above 8, which generated large tsunamis and caused severe destruction in coastal cities. Japanese government panels now estimate the probability of a new megaquake along the Nankai Trough in the next 30 years at roughly 60 to 90%, officially acknowledging that it could occur at virtually any time within a single human lifetime. Models suggest that such an event could generate tsunamis over 10 meters high along much of the Pacific coast from Kanto to Kyushu, with local peaks reaching 30 to 34 meters and a projected death toll in the hundreds of thousands plus enormous economic losses. Scientists are not saying that a megatsunami is guaranteed in the next few years, but they stress that the probability of a major quake and related tsunami in the coming decades is extremely high, and some scenarios allow for it to happen much sooner than 30 years from now. Burning belts, new megafire zones. Burning belts are new regions on the world map where large wildfires have become almost an annual norm rather than a rare disaster. Due to heat, drought, and strong winds, what used to be a seasonal fire regime is turning into megafires that cover vast territories and make entire regions permanently hazardous. To the classic fire-prone areas like Australia and California, new hot zones have been added. Southern Europe, Spain, Portugal, Greece, southern France, southern Canada, parts of Russia, Latin America, and North Africa. These places now regularly record record-breaking burned areas and longer periods of extreme heat, when a single spark is enough to start an uncontrollable blaze. Megafires can create their own weather, fire whirls, powerful updrafts, and thunderclouds that throw embers far ahead of the main fire front. Because of this, traditional firefighting tactics often fail, and the main focus shifts to evacuating people and protecting key infrastructure. For local residents, the threat is not only losing homes, but also chronic smoke, smog, respiratory problems, and disruptions to transport and airports. More and more cities once considered far from the forest now regularly find themselves under smoke plumes and effectively living on the edge of a fire front. The tropical dengue belt. The tropical dengue belt is a vast zone around the equator where the dengue virus has become a permanent part of life rather than an occasional outbreak. It includes most of Latin America, Southeast and South Asia, parts of Africa, and many Pacific islands. In recent years, this belt has seen record case numbers, millions of infections, and thousands of deaths, with the virus circulating almost year-round instead of only during the rainy season. As the climate warms, rainy seasons lengthen and cities expand, creating ideal conditions for Aedes mosquitoes, which transmit dengue. The danger is that this belt is slowly expanding. Dengue cases are increasingly reported outside the classic tropics, including in southern Europe and the United States, as infections arrive with travelers and tiger mosquitoes spread into new regions. In effect, a growing swath of the planet is turning into a continuous anomalous zone of viral risk. Mountains sliding off the map. In high mountain regions of the Alps, Himalayas, Andes, Pamirs, and the Caucasus, slopes were stabilized for decades by cold temperatures and permafrost locking rock and soil together. Now the ice within cracks is melting. This cement is turning into water, and seemingly solid rock masses are losing strength and beginning to creep down slope. As a result, giant landslides and rockfalls are becoming more frequent, with entire chunks of mountains, millions of cubic meters of rock, collapsing in a matter of minutes. Such failures can block valleys, roads, and rivers, forming temporary dams that later burst and send powerful debris flows downstream. The danger is that from the outside, these look like normal, beautiful mountains. Tourists and locals often cannot see that a slope is already unstable. At the same time, more roads, villages, resorts, and hydropower plants are being built in narrow valleys, right in potential impact zones where a single warm season or a series of heavy rains can trigger a local catastrophe.